It's great to be here. It's great to see some familiar faces as well. And I have a confession to make, KCD. This is probably the first talk I've done since KubeCon Amsterdam, so I'm a little rusty. You have to be kind to me. I'm really excited to be back here. It's a really lovely event. So just to introduce myself very quickly, I'm a principal engineer at AWS, and I'll dig into what I do a little bit more, but I'm obliged contractually to talk about, we are hiring, and I think AWS is a very exciting place to work. We do lots of interesting innovations, so please do check it out, see what we're doing, and I'll come to talk a little bit about what I actually work on professionally. So from this really cool video that Corey Quinn made a year or two ago, I work in region services, so it's building out regions. It's a very complex and very interesting piece of work because you get to touch all parts of the stack. And again, if you are interested, I'll put that QR code up at the end and check out some of the jobs there. They might be interesting. But that's not what we're here to talk about today. I mean, the thing that keeps me up at night existentially is the rise of AI. I'm a big Isaac Asimov fan, and the 3 laws of robotics were galvanized into my brain since about 15 years old, and I was paranoid ever since I saw that AI was taking more and more of our daily lives tasks over. None more withstanding than insurance underwriting. That terrifies me in particular. And the things that I really imagine AI doing, it's this kind of futuristic idea. And I think we're starting to see little inklings of that, aren't we? We're starting to see some things that are showing us a little bit of AI. Boston Dynamics, for example. Imagine that combining with ChatGPT. That's going to be an interesting exercise. But unfortunately, what we really get is a bunch of meme generators, which are quasi-useful. Even generating this slide deck, there's a Google option now for generating AI into the slide deck, and it's terrible. In fact, those sci-fi pictures were generated by AI, which is probably why they look very generic. So really, I'm being a bit facetious here, because it's not just this sort of stuff. There is also some interesting application of AI. For example, you've got the famous sort of autopilots on cars. You've got, as I mentioned, Boston Dynamics are now integrating some large language models and some foundational language models into their projects and into their vehicles. And again, insurance, medicine, mapping the genome, which has been completed, but applications to medicine and pharmaceutical companies we'll start to see in the next few years. But what does that have to do with anything? Well, before I get into why I'm interested in AI, I want to talk about how do we get here? Because it feels like suddenly we're working in computer science, we're working in software engineering, DevOps, whatever it might be. Suddenly AI is on the scene, and we all have to sort of put the brakes on and think, oh, right, okay, well, my AI strategy is now X, Y, Z. It's not by chance, and AI didn't happen overnight. I've tried to summarize it in probably the most useful facts that, to my mind at least, bring it to life. So I've just discovered there's a laser pointer on here. Meta released Torch in about 2002, and the reason I mention this is because ML is a subset of AI, right? ML is about building the artifacts that enable AI activities, which is effectively the synthesis of human behavior. And Torch was really fundamental. You hear PyTorch being mentioned, with a sort of reverence into how much it's used, similar to the way that Juniper really sort of took off and really cemented machine learning in a very accessible way for data scientists. Additionally, a few years down the line, OpenAI decided that they wanted to use some of this work in gaming. So OpenAI actually started to try and corner the gaming market in movies and entertainment, but quickly pivoted with OpenAI Gym to start to do more conversational style stuff. And they were kind of in a rut at that point because they'd built models and they were kind of useful, but the problem with those models is they were predictive on the next word in the sentence, and it was incredibly complex in terms of hardware requirements and also performance requirements to be able to predict things going. And really, the big change was in 2018, and I think we've all heard of GPT, again, K8sGPT, I'll come to that. The idea of BERT, so the bidirectional encoder, representations for transformers, really changed NLP forever, because what you could do is you could give a sentence structure, and that sentence structure would become normalized, and I won't go too much into this, but effectively it made it far, far faster to make accurate predictions on what should be responded to that sentence. If I was writing a nursery rhyme and I gave it the first sentence of that rhyme or a haiku, it could then accurately generate something useful. And I think really all of us, myself included, were exposed to this in November of last year. I went on ChatGPT like everyone else. I was pretty excited. First thing I tried to do was put in some Golang to see what it could do. And very quickly, I realized the corpus of text was a year or two out of date. And I thought, okay, this is interesting, but it has limitations. And also, it's not plugged into the rest of the internet, because then it would just be Skynet, of course. So how do we actually make something like this useful? We're in the Kubernetes space. We're talking about infrastructure. I've given you kind of a very compressed history of the past few years of why this is interesting? Well, working on K8s in particular as a substrate, you have tons of problems and issues all the time. Let's think of what what AI is really good at. It's really good at pattern recognition, right? So it's really good at looking at repetition in a lot of noise. It's good at translation, so it's good at taking that noise and creating signal out of it, right? It's also then good at predicting when that's going to reoccur. In my mental model, I think a lot about kind of a sine wave that's got many layers of noise occurring, and you're trying to pull out that carrier wave beneath it. But that's also quite funny because the problems I struggle with when I'm running Kubernetes are pattern recognition, translation, and prediction. For example, workload failure, looking at node failure, looking at hardware failure, looking at not just prognosticating, so the art of forecasting, but also looking at how did something go wrong? And it's super hard, right? We've had a talk about Argo CD. If a PVC fails because the NFS drive fails, or the SAN array fails, or the underlying hardware goes offline, or the Mellanox turns off for some reason, how do I correlate that back to my workload? And often you can't, and it involves a very deep knowledge of the stack. So I like working with Kubernetes. I've worked on it and with it for a long time. And I've got a huge amount of problems that I need to solve in K8s. As you know, it's not linear, the amount of problem complexity with Kubernetes. It scales probably, I won't say factorially, but it's certainly not trivial. So, let's think about, as a K8s admin, as a DevOps engineer, as a platform engineer, or as an enthusiast, how can I start to take some of those day-to-day problems and to reconcile them with the power of AI? It seems like a difficult thing to do. Well, I sort of thought to myself, I know that the error messages in K8s are really where most people go to, right? Whether you're looking at it through Splunk, whether you're looking at it in the K8s error logs directly, or whether you're looking at it through some CloudWatch tooling or something like that, usually people look at error messages or traces or metrics, and they try and figure out what went wrong. And that takes time. And the worst part of all of this is all the best SREs I know have this mental model of how every system works, and it's really difficult to put it onto paper. And by the time you do, it's already gone out of date. So the crystallization and the retention of knowledge is a key challenge here. So in a very simple example, similar to what I've said, something goes wrong. You have only a limited window to kind of filter that signal to noise to find your clarification. But what is interesting about this is we're all in it together. Every time I set up Argo and I can build repeatable conditions, for example, for that failure mode, there should be a way of giving at least best guess or best effort advice. And this is where it kind of culminated this idea of, well, I think I could codify some of this stuff. Some of this stuff isn't that arcane. Some of this stuff isn't that situational. And that's where K8sGPT came in. I was reading a book on marketing at the same time. It just correlates because I thought, wow, this is a great little hype vehicle right here. But in all genuine reflection, it does sort of encapsulate what we're trying to do with the project. It is about transforming the mode of messaging and the signals that you're getting out. So it's a little bit observability, it's a little bit runtime, and it's a little bit AI/ML. And I'll talk about that later, because the exciting part isn't we're not just consuming AI inference APIs. So what is it? It is a tool for scanning K8s clusters. I've been an SRE for probably almost 13 years in various jobs in different capacities at banks and tech companies, and picked up all sorts of interesting things. With Kubernetes, there's a lot of stuff that happens over and over, and when you get good at it, you can figure out a lot of it pretty simply. Services missing, PVC detached, disruption budget not set, that kind of stuff. And we all know a little bit of that. And I would invite you to come and contribute the bits that I don't know. So I thought, okay, I know Golang, I know Rust. Well, probably not going to use Rust. Let's think about what can we build. And so this was the first prototype. That Think Center 2 is my connected tailscale rig we're going to use in a minute for the demo. And you can see, you can sort of ask it, what's wrong with my cluster? I believe very strongly in this idea called a pit of success, and you can Google the term, but a pit of success effectively is what it says. It's make it so easy, people are like, why aren't you using this? It's a no-brainer. And so I wanted it to be a one-liner. You do a K8sGPT analyze, you get a bunch of cool stuff. And of course there you can see we're doing even cooler stuff with Trivy, and I'll get onto that later on as well. So diagnosing issues and giving simple instructions in English with an asterisk asterisks, we can actually translate this into effectively any language the AI speaks. So if you're looking at it in Arabic, you can also add an Arabic option, and it comes back in Arabic, which is kind of cool. So I got to work, and I just wanted to show this because I thought it was quite amusing. I got an AI to draw this, and it's really sort of weird kind of HAL vibes from Space Odyssey there. I did this abomination, and somebody on Twitter just tore me down for my lack of color wheel knowledge and design theory. And then I did another one, which I don't think was much better, but we're getting there. It's iterative process. That's engineering, right? And the project I started, funnily enough, at Amsterdam, I just went out onto Twitter and onto Slack, and I said, hey, who's interested in AI and who wants to help me build something for SREs, DevOps engineers, maybe even product owners one day to use? And we had a really good response. And we have about 30 core contributors. You might know some of them by the little tiny icons. I think some of them have spoken here, and some of them work in the space quite a lot. So what is it then? How does K8sGPT work? Let's get into it. I've just said it's a tool that takes K8's error messages, it takes logs, it takes metrics, it does all sorts of bits and bobs. How does it actually work? Well, the secret sauce here in this example is its codified knowledge. It really is. For example, this is a PVC check within a pod failure. And this is all open source. You can go into our GitHub and check it out. We actually check for things that an SRE would check, but we codify it and we run unit tests against it. And that's the first part of the equation. Once you've got that knowledge and you can understand, oh, well, I understand that failure mode, but I don't know how I'd tell someone, that's when you pass it off to the AI. You say, well, I've got the results. I think it's this. How do I munge that message together, send it into an LLM, and get it back into something that someone can understand? So that's the real value for me of AI here, is that the secret sauce is that we're taking codified knowledge and we're just simplifying it. We're not asking for hallucinations. I mean, yes, the AI can get it wrong in the sense of like, oh, well, I think to attach a PVC, you need to delete this, this, and this, and turn retain off. But it can't fundamentally change what we're telling it is the error from the cluster. So the architecture sort of works like this. You have a bunch of analyzers. I've just picked a pod analyzer because that's what we were running with as a theme. And what it does is it will connect to the API server, does a scan. You can set your namespaces, your security modes, all that jazz. It comes back with a list of pods. We then use the client Go API or the kubeRS API if you're feeling it spicy. And we can then say, OK, we'll go through about 15 different checks for each analyzer. If the check yields something happens, then we can go in and say, OK, well, this pod, in the case of the PVC example, has a status phase of not running. Why is that? And then we can go do an event check, and we can correlate these results together to figure out that effectively the underlying volume wasn't bound. We build this into a results package, which sounds very fancy, but it's just a struct. And then we have a selection of AI providers. From the get-go, I was really, really against using OpenAI as the only provider. And so there's a shim, there's an interface in front of all AI providers. K8sGPT, as I'll go into later, supports, I think it's upwards of 7. So Anthropic is coming soon. It supports Cohere. It supports Local, which is really cool, as well as Azure, OpenAI, et cetera, et cetera. So whatever your flavor, we've got an AI interface. But effectively, they're all starting to gravitate towards a singular API for AI. And when that comes back again, you get these enriched results, which is very exciting. What also happens is that when we send stuff off, in fact, let me just look at the difference between these. Yeah, when we send stuff off to this AI, it comes back through the analysis, and we can then print it out. I was just trying to encapsulate the 3 different phases of 3 different stakeholders. You've got the Kubernetes API server, your local CLI, and the AI API, inference API. Like if you're using Kubeflow, that would be Selden, for example, to serve. But that's not enough, because the CLI is great for some situations, but we're all about operators here, and especially co-authoring the operator white paper, I would be embarrassed to say I didn't write an operator. So there's an operator for this as well, which does effectively the same thing, except for it stores your results in the cluster. You can let this run on its own, and it will accumulate results, a bit like vulnerability scans or anything else. You can then put that into your pipeline. Shows up actually on Argo, which is quite cool as well, as a child resource. And we've had some really great success. We've even extended this now so that you can cache your resources in S3. GCS is coming soon, and I believe Azure Blob Storage, which I've forgotten the name of, is also supported. So let's have a look at a little demo of how this all fits together. I've got a terminal here, which I'm going to try and bring up. You'll have to give me a moment. Oh, hello. Tell you what, we're going to go back and turn on screen mirroring, because I think that's probably the key to success here. Right. Let's mirror. There we go. Wonderful. Now, let's make this a wee bit bigger. OK. So here I've got my CLI. I hope you can see it. I know that some people at the back might struggle, so I'm going to go do a bit of a narration of what I'm talking about here. So I'm connected to a cluster. I'm just using K9s as a visual tool to show you this cluster I'm connected to. This is my home lab. Now, I can put some pods into stress, right? So if we go to, again, I use Argo or Cert Manager or any one of these very popular tools at home. What we might do is we might turn down the CPU availability. So what I'll do is I will just do something like Argo Server, and I'll adjust that. I've got a million options on here. OK, I've got that turned on. Let's have a look. OK, change of plans. Rather than me sitting here and writing out limits and resources, I'll use a prefabbed answer that I did earlier on, which is there is effectively an issue with one of the service labels on an Argo CD POB, but I don't know that, right? So I'm just an administrator. Running K8sGPT, the first thing I want to do is say, well, OK, let's do an analysis. And so you go analyze E. This data, what it's doing in the background, it's running through all the analyzers. They're parallelized, goes off the API server, comes back again, and also then gives me an AI result on that. So in this particular scenario, we can see that the stateful set uses a service that doesn't exist. And this is a best practice piece here. So whilst it might not directly affect the stateful set because it's probably being called by either an ordinal directly or by an IP address, it is something that you might want to be aware of. So what you can do is, if you don't want to see that, you go through the filter list and you can turn filters on and off. Now, speaking about filters, I mentioned that we do something with Trivy and some other integrations. This is because K8sGPT is also built to be extensible, right? So it integrates natively with Prometheus as one of its prime integrations, but we're building more as time goes on. The integrations are effectively a way of turning on and off functionality. So let me give you an example. So we go K8sGPT, integrations, activate, Trivy. What's kind of interesting about this is that you can choose either to install it, you can do the pre-installed canned version, but for this demo, I just popped it on. What's interesting is you suddenly now get some additional analyzers, which is kind of cool. So I've got the vulnerability report analyzer and the config analyzer. And when Trivy is installed and turned on, this then will allow you to start pulling out AI assists for that. Now, what's interesting in the security context is that you can start prioritizing vulnerabilities based on whether they're applicable in the runtime. And we're just scratching the surface on this functionality. It was really done as a proof of concept to show that it's possible. Imagine what you can do if you start to bring in other tooling. Again, you could build an Argo or a Flux integration and start looking at whether your rollouts are working, whether they're jammed, just as a thought. This also works in harmony, more or less, with the operator, which can also run in the same cluster. So whilst I said I was going to spin up Trivy, which I think is sort of sat there somewhere doing something, you also then get this ability to manage K8sGPT through its own custom resource. And again, those at the back, effectively what I'm going to show you here is this is showing you your backend. Is it enabled, true or false? Does it have anonymization on, which is another cool feature, is that you can anonymize the data going back. And then is your integration active or deactivated? And so again, we can turn these settings on and off as we please. And what that yields, again, in a similar way, is we get our results that come back. So we're really trying to focus on making this something you can just slot into a workflow and not be this weird system that is a bit orthogonal to your processes. So again, it gives you this answer. We also have the ability to help you with understanding what the error message is and the error mode is by integrating with Slack and a few other webhook-based services. So it's kind of cool, but it could be better, right? Like, it's cool using OpenAI, it's cool using Azure and all that, but it could be better. What about trust? What about provenance of the LLM? Who trained it? It's not AWS Titan, so I don't know who trained it, right? And what's the corpus of data? Like, the corpus of data might be 3 years out of date, so it won't even know about modern incubating CNCF projects, for example. So we think about all this, and I thought, well, wouldn't it be cool if we could integrate with something? And so a friend of mine who works over at Spectro Cloud, actually, was coming up with this project at a similar time called Local AI. And this is a C++ wrapper around vector database models, and it effectively serves them locally. And you've probably seen by now on GitHub all the popular projects are some format of AI project that do some sort of serving. This one's really cool because it doesn't require acceleration. I don't know about you, but I can't afford an A100 to put in my lab. And what's really interesting is that it can do serving, but you can also then do fine-tuning on top, or hyperparameter tuning, if you so see fit. So when I saw this project coming out, I thought, aha, there is a really cool opportunity here to actually combine the two together. So what does that actually look like? Well, we see people doing this quite often. They will have some sort of distributed storage system. They will run Llama or GPT for all or some other model. They will load it in through the local AI deployment, and that serves an inference endpoint that's compatible with the K8sGPT deployment. And this is really interesting now because you're starting to be able to build your own form of AI ML control plane and workflow. It's really interesting as well because now I've suddenly decoupled myself from cost, but I have introduced an overhead. Inference APIs aren't free, they're very heavy, and so you want to start thinking about splitting this out somehow. And when people start splitting it out, they start thinking, well, actually, there's a real opportunity here, because if you've been following the news at all, you'll know that LangChain is an incredibly popular project for orchestrating different AI ML components. What we're starting to see now is that people are splitting out K8sGPT and running a training cluster where they'll use components like Katib, which is the hyperparameter tuning component that's just come out for Kubeflow. What this means is that based on the human operator response from the K8sGPT CLI, you can build a shim on top of the CLI. You can then feed that in as a LangChain pipeline parameter set that goes into Kubeflow. Kubeflow can then take an existing model and serve it through Selden back into K8sGPT. So within the year, we're starting to see that, which is a scary thing, is we're starting to see that we've got auto-correcting K8sGPT infrastructure. And I've debated a while now whether or not we should turn on the capability to actually do auto-remediation. And that comes with a lot of responsibility because hallucination becomes critical at that point. But we're getting within about a year and a half, I would say, of having the ability to do auto-remediation through AI/ML findings in clusters. Again, this also gives you the ability to solve for the security provenance. You know, if you've got a company who's investing millions of dollars in training your own models, and that's what it costs, and multi-years, if you are doing that, or you're using a foundational model from Anthropic or from Titan, then you can start to build upon those and add finding tuning parameters. Even with LangChain, you can add an additional vector DB in between to give context. So if your organization has just tons of Jira stuff, you can dump that into a vector DB, normalized, of course, and then you can add that when the K8sGPT deployment is trying to make inference for results. So you can say, I can see this issue. Go look at Jira issue 1966566665. And you will then start to build real value. And this comes back to my first slide about what makes AI/ML useful? Well, for me, it's actually accelerating the human experience rather than the kind of commoditization of memes and whatnot. So I don't actually work for a company doing this. This isn't my professional thing. It's just a pure open source project. And right from the get-go, I wanted to detach it from any commercial interest. So I donated, or started the donation paperwork almost straight away. It's still in progress. I think there's a few meetings and bits and bobs, but we're hopeful that in the next 12 months, we can get some traction on donating it perhaps to the CNCF. Orthogonally but related, there's also an artificial intelligence working group that we're looking to start, and I've put some Slack channels and some meetings together. If you are active in the CNCF, please do get involved, because it's an area that we need a lot more expertise than myself in. So what's next? Well, you know, this is an interesting opportunity to show the full cycle of how do we do auto-remediation, training, and showing value in Kubernetes. I think we need to aim bigger. So I think the next thing is that we need to write it in a proper programming language, and we need to make it an even broader scope. So really, we'll be looking at Ferris here to see what we can do, and actually looking at Linux hosts in the cloud and thinking about broadening that to use something like SageMaker to really build a full life cycle set of components. But I don't want to speak too much about that, otherwise I'll give too much of my KubeCon talk away. So really, thank you very much. The left one, it's pretty silly of me to put these both on the same page, because you can get your phone's going to go nuts. Left one is the project. That's the K8sGPT GitHub. If you want to try it right now and you want to complain to me before I leave the building, it's brew tap install K8sGPT-AI/K8sGPT and then just brew install K8sGPT, or go and look at the instructions. And the one on the right is that we're hiring. So again, thank you so much. It's been a pleasure, and I hope this was interesting. Cheers. Pardon? Oh, yeah, sure. I've just been informed we have time for questions.
Does anybody have any questions?
So I wonder what your view is on, instead of auto-remediation, like things short of that. So one of the options would be generating a pull request, but there's a lot of options. So what's your opinion?
Yeah, I think auto-remediation sounds great, but it's just, I mean, having worked in banks and highly regulated companies, it's just, it's a bit of a pie-in-the-sky dream that the AI would ever be that accurate to be able to restart things. And also with service complexity, it might say, oh, Argo stopped working, I'm going to just pull this plug out and plug it back in, completely unaware of the 5,000 people depending on that service. So I don't think we're quite there yet with auto-remediation. We actually do have a PR in flight right now to associate a GitHub repo with a particular resource and open a PR. And I think that's a much more practical way, is to have humans involved at some element. But yeah, I think we're kind of, I think we're kind of thinking about this in an incremental way rather than just going, hey, it's all singing, all dancing, because there's no surer way to destroy a project than to lose your credibility by just going with some crazy initiative like that.
How do you stop the model getting poisoned and maybe, somebody intentionally allowing Kubernetes GPT to make bad decisions based on a poisoned data set?
Would you mind repeating the first part of that question?
How do you stop the model getting poisoned?
Right, right. So that's an interesting one. And it's funny because it reminds me of Dan's talk earlier about supply chain. I think we also need to think about that through the lens of LLMs as well, right? Foundational models are now being heralded as the new template for producing any meaningful model. So that, I mentioned it earlier on, but models are very expensive to train. Many people who have been downloading things like Llama have effectively just been taking the corpus of data that's come from Facebook. And I think that when you start to have lots of people thinking about AI, of course, bad actors are going to come along with it. Model poisoning, and in terms of how do we know that hallucinations aren't becoming prevalent, is a difficult thing to think about. But in that previous diagram I had, the evaluation with LangChain and K8sGPT requires a human operator to kind of verify, yes, this was the right solution. So I don't have a direct answer for how we will stop the integrity of a model being compromised, other than the usual trappings of, SHA and integrity. I think there's more to it than that as well, because whilst the model size and the model might be a sort of a finite and a known quantity, the actual pathways inside the weighting can be modified based on the training set. And again, this is where you kind of need to think of that secure supply chain, even through to the people training models as well. So it's a really interesting field that I don't have a lot of experience or answers for yet, but interested to find out more.
Okay. Any other questions? No.
Yeah, I'm willing to have a second bite at the cherry and ask, do you recommend running K8sGPT inside the cluster it's analyzing?
It's an interesting question. It doesn't detect itself. That's an interesting kind of comment, just purely because it's fairly light and doesn't have a lot of things that are to break in it. But there are some downsides, I'll be completely frank. It needs high-level cluster permissions. It needs high-level RBAC to be able to run in the cluster, because you are scanning custom resource types. You need to list them, get them. I still think it's an effective tool in the cluster for small companies who are resource constrained, right? Because you can go and say, okay, well, fire me out a Slack alert if the list goes above, say, 3 or 4. And we know we've probably got an indicator. So when I've framed this to things like the CNCF tag observability, I framed it as it's a signal generator, much like Prometheus is, much like Jaeger is. You could use this as a signal generator. So I think there is value. Where I see it being more useful in the CLI format is for folks who don't have necessarily expertise, but also for for gating in CI/CD. You can run a CI/CD gate with kind in K8sGPT running on the deployed resource to say, okay, I can see there's an issue here. our AI has told us that you've got the Jira docs here, here, and here. And so within 5 years, we're going to see banks are starting to equip people with run books for how to remediate challenges they're seeing in the CI/CD workflow.
Okay. Well, thank you very much again, Alex. Let me give him a hand.
Thanks.